All right, I want to talk about section 9.8, solving equations with the Pythagorean Theorem. Kind of screwed up my spelling over there, but we'll just pretend that everything's okay. Recall last time that we were talking about the Pythagorean Theorem, and the Pythagorean Theorem states that whenever we have a right triangle, which means that a triangle with that right angle in it, right? And we name these sides A, B, and C, we can notice that there's a relationship between the sides. And A squared plus B squared equals C squared. So if I square the two sides and add them together, the hypotenuse, the square of C, is equal to that. And last time we were given some measurements for A and B and then told to find C. But we can also go backwards the other direction, and that's what we're going to be talking about today. I'm probably just going to do a couple of examples because I don't think it's particularly difficult. Okay, let's take our favorite little triangle. And this is going to be a right triangle, and we have 3, 5, and B. And we're going to solve it using the Pythagorean Theorem. So instead of missing the hypotenuse, we're going to be missing one of the sides. So I'm going to write my equation, my Pythagorean Theorem. A squared plus B squared equals C squared. I have 3 squared plus B squared equals 5 squared. 9 plus B squared equals 25. Do my simplifying step. Subtract 9 from both sides because I'm trying to get rid of this. I have B squared equals 16. I'm going to take the square root of both sides, and now I have B equals, the square root of 16 is 4. Now a trick is, this is one of the most famous right triangles. It is called the 3, 4, 5 triangle. And it's one of the few triangles that all the numbers are whole numbers, and it's really, really easy. So if you ever see a right triangle and you see a 3 and a 5 or a 4 and a 5, you pretty much know the other direction. And it's often used in examples. As you can see, I even just use it because it saves time. I don't have to use a calculator. Let's take a look at another quick example. We'll call this example 1. And pretty much the ones you're going to be doing today are all like this, so I don't anticipate it being particularly difficult. We have A, we have B, which is 6, and C, which is 13. Okay, let's go through our steps again. I'm going to write out my formulas first, because I always like to do that. And now I'm going to plug in what I know. A squared plus 6 squared equals 13 squared. A squared plus 36 equals, that is 169. I thought so. Subtract 36 from both sides. I have A squared equals 169 minus 36. That is 133, right? Yep. Now I take the root of both sides. And remember, it's nice when I do this. I don't have to worry about my negative root because I'm working with geometry. And I have A equals, and I'm going to take the square root of 133, which is about, we'll say A is about 11.5, because I can round to the nearest tenth. All right, if you feel like you get it, go on. I'm going to do one more quick example, mostly just because I have more space on my page. And these are kind of fun. And, all right, let's take a look at this one. And in this right triangle, oops, I forgot to label my last one. I have A is 6, B is unknown, and C is 10. Okay, let's go. A squared plus B squared equals C squared. 6 squared plus B squared equals 10 squared. 36 plus B squared equals 100 minus 36 from both sides. It's a terrible 36, sorry. And we have B squared equals 100 minus 36 is probably 64. Is that right? It is. Of course. And our roots of both sides, we have B equals 8. And I should have noticed, this is a 3, 4, 5 triangle. They just multiplied all the dimensions by 2. That was silly of me. And there we go. Good luck, and go on. Oops.